Alright, so this video we're going to take a look at sum and difference identities for sine and tangent. And if you were wondering where cosine is, that was in the video right before this one in the playlist. So you can, if you're not in the playlist, you can search my channel for sum and difference identities for cosine if you want to watch that one. Alright, so let's go ahead and get started. So let's just look over the sum and difference identities for sine and tangent. And what I would do if you're watching this video, you got you a piece of paper and pencil sitting there, write the identities down so you'll have them as we go through the video, and that'll keep me from having to scroll up and down to go back to the formulas. All right. Because when we scroll up to work the problems, we won't have the identities there, so at least you'll have them written down on a piece of paper. All right, so for sine, it's sine alpha is equal to sine alpha cosine beta plus cosine alpha sine beta. And then sine alpha minus beta, you can see it is similar to the first one. They're the same, except the sign in between them is different. All right, so, you got to memorize them. So memorize the first one. If you know the first one, you know the second one. So they're both the same. And see the plus here, there's a plus there. Minus here, there's a minus there. Cosine's similar, except for on the cosine, when there was a plus, there was a minus. And when there was a minus, there was a plus. Check that video out or look at your cosine, your sum and difference identities for cosine. And now tangent, we've got tangent alpha plus beta is tangent alpha plus tangent beta minus tangent alpha tangent beta. And you can see these are the same also, except it's just the signs are opposite. You see that? All right, so other than that, this is pretty easy. Okay, so let's take a look at it. So find the exact value. We've got sine of 195 degrees. Now, they want us to find the exact value, so no calculator. So what do we know the sine, cosine, and tangent of? If you've been watching the other videos that I have in this playlist, you've probably gotten sick of hearing me say this, but you've got to memorize sine, cosine, and tangent of 0, 30, 45, 60, 90, 180, 270, and 360 degrees. You've just got to remember them. Okay? You've got to know those. So let's look at this. We've got sine of 195. So if we look at 130 and, so if we look at 30, 45, and 60, if we look at 30, 45, and 60, there's nothing we can add there that'll give us 195. But what we can do is we know that this is equal to the sine of 150 plus 45, right? All right. So why did I choose 150? Because 150 was not one of the angles that I said you need to memorize. Well, 150, if we find the reference angle for 150, what's the reference angle of 150? Well, that's going to be 30 degrees. And if you're not quite sure how I got that or where that came from, just hang on for just a second and I'll show you in this problem here. All right, so what we're going to do here, we've got sine of alpha plus beta. So sine of alpha plus beta. So I'm just going to expand it out. Alpha is 150, beta is 45. All right. So this is going to be sine 150 cosine 45 plus cosine 150 sine 45. All right, so all I did, I just wrote the formula out. All right, so let's see what we can do with this. So this is going to equal, so I need to know the sine of 150 and I need to know the cosine of 150. So I'm going to come over here to the side and I've got 150 degrees right here. And the reference angle, here's my reference angle. So my reference angle is 180 minus 150. So my reference angle is 30 degrees. See, I've got the 180, and then I subtract off the 150. I'm left with 30 degrees there. Remember, your reference angle is always measured off the x-axis. And if you're not real sure on reference angles or need a refresher on that, you can go back in this playlist and there's a video on reference angles. You can watch it. All right, so we've got our reference angle is 30. So how do we do that? Well, the sine of 30, so the sine of the reference angle, the sine of 30 is 1/2. All right. I'm in the 150 is in the second quadrant. Sine is positive in the second quadrant, so the sine of 150 is 1/2. The cosine of 45 is square root of 2 over 2, plus, and then I've got the cosine of 150. Well, what's the cosine of 30, our reference angle? That's what? Square root of 3 over 2. I'm in the 150 is in the second quadrant. Cosine is negative in the second quadrant, so that's negative square root of 3 over 2. And then the sine of 45 is square root of 2 over 2. All right, so if you remember reference angles, whenever you take the sine, cosine, or tangent of the reference angles, that gives you the value, like in this case, 1/2 and square root of 3 over 2. But then you've got to go and see what quadrant the angle's in and determine if it's positive or negative. And so this is going to be square root of 2 over 4 minus square root of 6 over 4. So this is square root of 2 minus square root of 6, all that over 4. And there is your answer. All right. So hopefully that made sense. Basically, I'm just writing out the formula. That's all I'm doing. Okay, and then evaluating each one. All right, so let's look at our next example. I've got tangent of pi over 12. All right, so I need to break this up. So remember, we know the sine, cosine, and tangent of 30, 45, 60, 180, well, 90, 180, 270, 360, and 0. So we know that. So let's look at 30, 45, and 60 degrees. Well, remember, 30 degrees, 45 degrees, and 60 degrees. And we're not in degrees, we're in radians. So let's write the radian measure down for each one. Okay. But look, when you think of 30 degrees, you ought to know that's pi over 6 in radians. Same thing with 45 and pi over 4, 60 and pi over 3. You've got to know that. That's the stuff in trig that you have got to remember. You've got to memorize that stuff. Okay. Now, my denominator here on my angle is pi over 12. My denominator's 12. So let's write these with a denominator of 12. And let's see what we can do. So what do I multiply to 6 to get 12? 2. So 2 times pi is 2 pi. This one would be what? 3 pi, and this one 4 pi. All right, so what do I have? Okay, I've got, look at this. See this 4 pi over 12 minus 3 pi over 12 is pi over 12, right? You see that? If I do this one minus this one, that gives me pi over 12. So this is tangent of what? Pi over 3 minus pi over 4. I'm writing it the reduced term, okay? and look, yeah, if you wanted to, you could do 3 pi over 12 minus 2 pi over 12 and get the same answer, okay? All right, so let's write this out. Tangent alpha minus beta. So we're going to use this one right here. I got tangent alpha minus beta. Alpha is pi over 3, beta is pi over 4. So we're gonna plug all that in. So I've got what? Tangent of pi over 3 minus tangent of pi over 4. All that is over 1 minus tangent pi over 3 times tangent pi over 4. Right? So now we've got to simplify this. So tangent of pi over 3, or tangent of 60, that's what? Square root of 3 minus tangent of pi over 4. Tangent of pi over 4 is 1. And then that's 1 minus tangent of pi over 3 is square root of 3. Tangent of pi over 4 is 1. So that, well, let me write it down here. So that's going to be square root of 3 minus 1 over 1 minus square root of 3. Oh, I'm sorry. And you know what I did? I wrote the formula down wrong. That should be a plus there. How about that? Okay. I had a minus there. That should have been a plus. All right. Plus here also. All right. So here's our answer. And as you know, we don't want to leave it like that. We've got that square root in the denominator. Okay, we've got that square root in the denominator. So let's rationalize the denominator. So we're going to multiply numerator and denominator by 1 minus square root of 3. So if I fold this up here, that's going to be square root of 3 first, outside, minus 3. Square root of 3 times negative square root of 3 is 3. And then negative 1 times 1 is negative 1. And then I have negative 1 times negative square root of 3 is square root of 3. And that's over, this is a plus b times a minus b. So that's 1 squared, which is 1, minus square root of 3 squared, which is 3. Or negative 3. All right, so what do we have? Let's see. That is going to be negative 4 plus 2 square root of 3 over negative 2. And look at this. See the negative 2? It divides into both of these evenly. The negative 2 does. So negative 4 divided by negative 2 is 2. And 2 divided by negative 2 is negative 1. So that's minus square root of 3. And there's your answer. All right. Sorry about that little mess up there on that plus when I had the minus instead of the plus. It happens. Okay. All right. So let's look at this one. Use an appropriate identity to simplify each expression. So hopefully you can tell here the problems here are they're already expanded, and they want us to write it as alpha plus beta or alpha minus beta, whichever one it is. So if we come back up here, basically what we have is we have this side over here, and we need to rewrite it into this side over here. So you can see we have, in our problem, we have sine alpha cosine beta plus cosine alpha sine beta. So we're going to rewrite it as sine alpha plus beta. Hopefully you wrote the formulas down at the beginning of the video. But this is going to be sine of 7 degrees plus 2 degrees. All right, which that is sine of 9 degrees. And that's all that you can do. That's as far as you can take it. I mean, yeah, you could plug it into your calculator, but we'll just leave it like this. Okay, we're just simplifying it as much as we can without a calculator. All right, all they're wanting you to do is get practice with the identities, writing them both ways. Okay. All right, so let's look at this one. So the problem we have here, we've got these negative angles in there. See, we've got the sine of negative t, cosine of negative t, sine of negative 2t. So let's get those out, and we can take care of that. Remember, with the negative angle identities, remember we've got sine of negative theta is equal to negative sine theta, and we've got cosine of negative theta equals cosine theta. And they have ones for the other ones, like tangent theta. Tangent of negative theta is equal to negative tangent theta. And then their reciprocals, they're similar. Okay, but all we're dealing with right now is sine and cosine. So let's rewrite these angles as positive. So that's going to be negative sine t cosine 2t minus cosine t, because cosine of negative t is just cosine t. This minus is this minus. All right. And then that's times negative sine of 2t. And so this is going to be negative sine t cosine 2t plus cosine t sine 2t. So the negative and negative here make a positive. And so I've got a negative out front here, so I don't want that. Okay, I don't want that. So I'm going to factor out a negative. So that's going to be negative, and then I've got my parentheses, sine t cosine 2t minus cosine t sine 2t. All right, see, when I factor out the negative, it changes this term here to a positive and changes the sign of this term here from a positive to a negative. And now we get negative. Now let's go up to our sum and difference identities. I'm not going to scroll back up. You've got them written down. So that's going to be sine of t minus 2t, which that's going to be negative sine of negative t. And can you guess what this is? This is just what? Sine t, right? See the minus here? Because look, if we rewrote this, let me just come over here to the side and do it. So negative sine of negative t, that equals negative sine of t, right? Using the negative angle identity. And then the negative and negative make a positive, so that's just sine t. All right, just a little algebra there. That's all that is. You know how to do algebra now. You're in trig. All right. Let's see what we've got here. Find the exact value of sine alpha plus beta if sine alpha is negative 3/5 and cosine beta is negative 1/3, with alpha in quadrant 4 and beta in quadrant 3. All right. So we can do this. This isn't difficult to do. So what I like to do, and if you watch the video before this one, sum and difference identities of cosine, it's worked the same way. It's just the formula's different. And you'll notice if you continue watching these videos in this playlist, when we get into the double angle and half angle identities, you'll know they're all work the same. It's just different formulas. That's all it is. Don't make this stuff harder than what it is. And so we've got what? We've got, let me write the formula like this. I'll write it. Sine of alpha plus beta. Let's peek back up here. Remember the formula. Sine alpha plus beta. Sine cosine plus cosine sine. Okay. So we've got, all right, so what do we have? We've got sine alpha cosine beta plus cosine alpha sine beta. Okay, so all I've done is written this formula out. That's all I did. I just wrote the formula. All right, So let's look at this. They give us sine alpha. You see that? We're given sine alpha. And we're given cosine beta. So we got to find these two. And once we find those two, we plug everything into the formula, and then we got it. Okay? So let's go ahead and find, it doesn't matter. Let's find cosine alpha first. All right. So I know that sine squared alpha plus cosine squared alpha equals 1, right? And what's what's sine alpha? Sine alpha is negative 3/5. So that's negative 3/5 squared plus cosine squared alpha equals 1. So that's 9/25 equals cosine squared alpha equals 1. And then we're going to subtract 9/25 to both sides. So I get cosine squared alpha is equal to 16/25. Yes, you know how to add and subtract fractions. All right, that was a long time ago, wasn't it? But you should still know how to do that. Just remember that 1, that's 25/25 minus 9/25. There's your hint. All right, so now we get cosine alpha is equal to, now remember this is square root property, so cosine is equal to what? Plus or minus the square root of plus or minus the square root of 16/25, which is plus or minus 4/5. So cosine is negative 4/5, or cosine alpha is positive 4/5. All right, so how do we know which one's the answer? Well, we go back up here to the problem. Alpha is in quadrant 4, and we know that cosine is positive in quadrant 4, so we cross out the negative. And so now we've got cosine alpha. Now we need to find what? We need to find sine beta. And guess what? We're going to do it the same way. All right. So I've got sine squared beta plus cosine squared beta equals 1. And we've got cosine beta. So I get sine squared beta plus negative 1/3 squared equals 1. So sine squared beta plus 1/9 is equal to 1. I'm going to subtract 1/9 to both sides. So sine squared beta is equal to 8/9. So sine beta is equal to plus or minus the square root of 8/9. So that's going to be negative 2 square root of 2/3, or sine beta is equal to 2 square root of 2/3. Square root of 8. 8 is what? 4 times 2. Square root of 4 is 2. Just reducing the radicals. All right, that's all we're doing. All right, so once again, which one is it? Well, beta is in the third quadrant, and sine is what in the third quadrant? It's negative. There's your answer. And wow, look at this. We've got sine beta now. Do you see what I did? All I have done is written down the formula and found what I needed to plug into the formula. That's it. Okay? That's it. That's all you have to do. So let me go ahead and pull this formula down here so we can have it right here. All right, so what do I get? I get sine alpha plus beta is sine alpha. Well, what's sine alpha? Let's go back up here and look. Negative 3/5. Negative 3/5 times cosine beta. Well, what's cosine beta? Negative 1/3 negative 1/3. Right. Yep. And then plus cosine alpha, which is what, 4/5, times sine beta, which is negative 2 square root of 2 over 3. And so this is going to be negative 3 over 15. Yes, I know the 3's cancel. And I also know that it's positive and not negative. Okay? Negative times a negative. I know the 3's cancel, but I want to keep the 15 because I want a common denominator to combine those. Minus 8 square root of 2 over 15. And so this is going to give me 3 minus 8 square root of 2 over 15. And there is your answer. All right. Look, I worked 2 problems in the last video with the cosine sum and difference identity. Go watch that. It's the same thing. If you need to see more of this, watch that video right before that. It's the 2 problems I work at the end of the video. Okay, go watch them and give you practice. But all it is, they ask you to find sine alpha plus beta, or sine alpha minus beta, or cosine alpha plus beta, or cosine alpha minus beta. Write the formula down and then find what you need. That's it. All right. Okay, so here this is the last one, proving an identity. And look, I know I didn't do one. They asked us to find tangent alpha plus beta, but it would be the same thing. And actually, finding tangent alpha plus beta, you could actually, if you wanted to, you could find sine alpha plus beta and sine and cosine alpha plus beta, and then tangent alpha plus beta is just the sine over cosine. Remember that? You can do that too. All right, so let's prove this identity. So what we want to do here is let's take the left-hand side and see if we can simplify it to the right-hand side. Okay, so let's take sine of alpha plus beta over sine alpha times what? Sine beta. Well, I wonder what in the world we're going to do right now on our first step. What do you think? Pause the video and think about it for a little bit. And if you guessed we're going to expand that sine alpha plus beta, we're going to write that formula down, then you have guessed right. All right. So let's just write out the formula. So that's what? Sine alpha cosine beta plus cosine alpha sine beta. And that's over sine alpha sine beta. All right. Now I wonder what we're going to do. Well, the right-hand side split up into 2 terms, right? 2 terms added together. So don't you think we might split this fraction up? Let's try that and see what happens. So that's going to be what? Sine alpha cosine beta over sine alpha sine beta plus cosine alpha sine beta over sine alpha sine beta. All right, so let's see what happens here. Look at that. Sine alphas cancel out. Sine betas cancel out. And I am left with, look, cosine beta over sine beta plus cosine alpha over sine alpha. And what do we have? Well, that's what? That's cotangent beta. And that's what? Cotangent alpha. And is that the right-hand side? It is the right-hand side. Except the only difference is cotangent alpha comes before cotangent beta. Same thing though, right? But if it makes you happy and makes you feel better, just switch them around. That's all you got to do. And there it is. Okay? Because we know that 2 plus 3 is equal to 5, and we also know 3 plus 2 equals 5. Commutative property of addition. All right? All right, so look. This isn't that bad. Look at the sum and difference identities for cosine, that video. Look at this video that you've watched. Only took me around 30 minutes to do it. That's a section in the trig book. That's a section in a trig book. Each one is. Got cosine, sum and difference of cosine, that's one section. Sum and difference of sine and tangent, that's another section. Didn't even take long for me to go over this. So it can't be that difficult, right? So, the key to it, know the identities. That's it. And the video after this one, okay? You want to watch that video after this one, double angle and half angle identities, guess what? It's going to be just like this pretty much. The only difference is the formulas are different. That's all. But you go about working them the same way. Like with these double angle identities, if they ask you to solve for something, if they ask you to find cosine 2 alpha or sine 2 alpha, write the formulas down. Plug in. If you don't have everything you need for the formula, find what you don't need. That's all it is. Same thing for the half angle identities. It's the same thing. But with the half angle identities, I will say this, it's not that bad, but it can be a little more difficult to simplify those answers. The algebra gets a little nastier with those. So, watch that video for the algebra stuff. You'll learn some stuff there. All right, so I hope this video helped. Check out my other videos. Give me a like, share, and subscribe. And I will see y'all later.